Artificial neural network. So this concept is derived from the human brains, and there are neurons present in the human brains, and that is taken from this concept, that is the neurons in humans. There are totally 10 to the power of 10 approximately, or more than that, neurons present in the human brain. So this concept, let us look at this the concept more, and the applications of these are the speech recognition and image classification and financial prediction. Here the speech voice is taken and it is predicted what is the voice, that is which voice, whose voice, and what he is talking, and you can predict it. So that is speech recognition. Image classification is the image is taken and the image is identified what image it is. And the next one is the financial prediction. So it predicts the financial situation which we give based on the input we have given. And let us look at human brain neurons. These are the two neurons present here with the nucleus, and these are the branches present to these neurons. And nucleus is, there are two neurons that is connected, and symphysis is the one which connects between the two neurons. And this is some small and artificial diagram of a human neurons present. And axon is the one which connects between the two neurons. This explains the two single and multi-layer network. The first one is the input is given and the weights are calculated and output is calculated for this, and this is a single layer. And in a multi-layer, the input is taken, and with the weights, the output is calculated for this. So this is the single layer linear one, and this is the multi-layer neural network. And the different parts of this is the input, weights, and the hidden layer, and finally the output. Here an example for this is the truth table, and the truth table of OR. So OR truth table is the input, and the input of 1 1 should be 1. So and the weights here, W0 is -10, W2 is 20, W3 is 20, and the input is given and the output value is 1. And W0 is the pass, that is the value that is given, and that we calculated. Now perception. So artificial neural network discussed here is based on the unit called perception. Perception takes the vector of the real valued inputs, calculates the combination of these inputs, then outputs 1 if the result is greater than 1, greater than 0, that is the threshold, and -1 otherwise, where W0 is usually a threshold. Now given the inputs x1 and x1 to xn, given the input x1 to xn, here x1, x2 to xn are the input, and the value, if this statement, that is sigma w1 to wn, that is these sigma values, that is w0 plus w1 x1 to wn to xn, if it is greater than 0, then the output is 1. -1, if it is -1 or less than -1, then it is 0. So that is what it is. Sigma I is equal to 0 to n, wi and xi is the sigma value of it. So for x0 equals 1. So that is, here we are multiplying it 1 plus w0, and this is the threshold. That means the threshold is the minimum value, the value that it has to pass through. So that is the minimum value that it has to pass through. And here you have the representation of this neural network. So input x1, x2, xn are the input, and w0 is the threshold to it, and it is reaching till wn, and that is sigma I equals 0 to n, wi and xi, where w0 is the threshold, and this is the output. If it is greater than 0, then it is equal to 1. Now let us consider OR and its truth table, and where 1 1 here, 0 0 is 0, 0 1 is 1, 1 1 is 1, and 1 1 is 1. And now if it is 1 1 is 1, then the input to this truth table, so input 1 and 1, if this is the input and this is the threshold, that is minus 10, the value sigma should be more than 10, so it becomes 0 if it is plus 10, so this is the threshold value W0 and it should be more than this. So that is W1 is equal to 20, and let's consider W2 is equal to 19. So the output, if it is 1 1, the output is 1. So sigma I is equal to 0 to n, W of I into X of I will be W0 into X0, where X0 is equal to 1, and W1 plus into X1 plus W2 into X2 to Wn to Xn, and finally we get X1 is equal to 0, and total, if I calculating this one, the sigma of Wi into Xi is equal to 1. So the output is 1. Now the perception outputs 1 for the instance lying on one side of the hypothesis plane, which is linearly separable. This is linearly separable. One is all positive one side and negative one side, and this is non-linearly separable. So because we have a distribution of the positive and negative side over the entire area. Now, the perception can represent all primitive Boolean functions and, or, and XOR. Thank you.